All right, getting deep into the equilibrium pit. You're going to do a lot more work with equilibrium. Remember, a lot of algebra skills are required, and this is just one first instance of the algebra skills that you've had to do some before. Here's another example. We'll show you more equilibrium problems in the next chapter, but let's get to this one. It says a mixture of 2 moles of CO, 2 moles of H2O is allowed to come to equilibrium in a 1 liter flask. The equilibrium constant is 4.0. It wants you to calculate the concentration of H2, one of the products. So I give you the equilibrium constant, and you have to have molar concentrations. But in this case, I'm telling you it's 2 moles of each of these reactants in a 1 liter flask. So at the end of the day, it's 2 divided by 1. It's 2 molar for both of these things. And so it's 3 sig figs. I'm just going to put that off to the side, because that's going to make things easier for me. And just keep note of the 3 sig figs. And so how do I deal with this? Well, now that I know the initial concentrations, I can write down an ice table and say that I start out with 2 molar this, CO, 2 molar H2O, and I have nothing of CO2 and nothing of H2. How is it going to change? Well, I'm going to reduce CO by X. I'm going to reduce H2O by X. I'm going to increase CO2 by X, and I'm going to increase H2 by X. All the stoichiometric coefficients are 1, so I don't need to worry about adding any other stoichiometric coefficients. I have my full expression of changes in terms of X. What are the equilibrium concentrations? Well, it's going to be, how is CO going to change? It's going to start off with 2. It's going to reduce itself by X. H2O is going to start off by 2. It's going to reduce itself by X. CO2 is going to start off at 0, increase by X. So CO2 and H2 are just X. Okay, let's write down the equilibrium expression. It's the concentration of CO2 times the concentration of H2 divided by the concentration of CO times the concentration of H2O. And now just point out that H2O is a gas, so I do need to include it in the expression. And that's what I'm looking for. The equilibrium expression then, now that I have all of the equilibrium concentrations, I can put them in. So that means that I have X times X in the numerator and 2.2 minus X times 2 minus X in the denominator. That all equals the equilibrium constant, 4.00. Now this is where your algebra skills come in. What you're going to get is you're going to get a quadratic formula. And if your algebra skills are weak, you're going to try to solve a quadratic formula using the quadratic equation. Strong algebra skills say, I've got perfect squares everywhere in this expression. And so I can take the square root of everything. The square root of X squared is just X. The square root of 2 minus X, quantity squared, is just 2 minus X. And the square root of 4 is 2. And so now I've simplified the equation into something that's not a quadratic. And so I can directly solve. So multiplying both sides by 2 minus X, I get 2 times 2 minus X equals X. Continuing to simplify, running through the parentheses, I get 4 minus 2X. Combining the x's on both sides, I get 3x equals 4. And so x equals 4/3, which is 1.33. And it's 1.33. That equals x. The question asked me to figure out the molar concentration of H2. And the molar concentration of H2 is x. And so that's the final answer. It's 1.33 molar.